Okay, folks, we are going to skip the proving right triangles congruent and go to isosceles triangles. We'll do the other one when I come back. But isosceles and equilateral triangles, we've indirectly or informally talked about these triangles this year. To be honest, you've probably learned about them in elementary school. I'm hoping right now that you're thinking an isosceles triangle has 2 legs the same and an equilateral triangle has 3 legs the same. Those are probably things that you hopefully just remember from a previous math course. But now today we are going to formally talk about them and do some things with them, all right? So let's just kind of first talk about like the anatomy or the parts of an isosceles triangle, because there's kind of a lot to know. So, I'm just a little short. Hold on. Sorry, folks. There we go. Okay, so our 2 congruent sides of our isosceles triangle are called the legs. Okay, and then as we label things like up above, let's label them on our picture. So do you guys see how we have 1 tick mark and 1 tick mark? So then I would know that A, B, and B, C are our legs. That's a leg, and this is a leg. Okay? Now, the angle where those 2 legs intersect, so this angle B, do you guys see how this intersects right here? These 2 legs intersect at B. That's called our vertex angle. Again, very helpful if you label this on your picture. So angle B is our vertex angle. The side opposite that vertex angle, so our other side that's not a leg, down here, AC, that's called our base. And typically when we draw an isosceles triangle, it looks in the orientation that it's in now, and you can think kind of base as the bottom, right? So this green side down here is our base. And then those 2 angles along the base are called the base angles. Again, math people aren't too creative. That's what they are. They're on the bottom and they're angles, so they are base angles. Again, that would be angle A is a base angle. And angle 3. Again, if I'm going too fast, pause the video, get all of this down. It's good information and it will be helpful, all right? Base angle. Because your base angles are across from 2 congruent sides, they are also congruent. So I want you to mark that somehow on your picture, right? Mark these congruent angles. Like I know angle 2 is congruent to angle 3. They're the same because they're from congruent sides. So that's kind of our little segue for these 2 theorems. So our isosceles triangle theorem says if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So that's saying we have our 2 legs that we know are congruent, then I know our base angles are congruent. So in our picture up here, if segment AB is congruent to segment BC, then angle 2 is congruent to angle 3. Now the converse, remember converse just means to flip the order. So the converse of the isosceles triangle theorem says if our 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So if we know angle 2 is congruent to angle 3, then segment AB is congruent to segment BC. Beautiful. Okay. So let's practice looking at a diagram and seeing what happens. So it says, use the diagram to answer the following. Name 2 unmarked congruent angles. So if I look, what angles would I know are congruent? Well, I'm probably going to be looking for 2 congruent legs. So I see a leg or segment markings there, right? So what angle is across from this side? Well, that's angle B. So I know that angle B is congruent. And what side or angles across from this side? This angle right here. But since there's multiple angles coming from C, we have to use 3 letters. So that'd be angle ACB. 2 Perfect. 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 2 name two unmarked congruent segments. So again, those would be across from congruent angles. So if I have this congruent angle, it's across from segment AC. And if I look here, this angle in the corner, DCA, is across from this side here, and that would be AD. Okay. Same type of questions down here with a little bit more of an interesting picture. I challenge you to pause the video and try these on your own to see if you can figure it out, but I'm going to go ahead and start. Name two unmarked congruent angles. So again, we're looking for two congruent side markings, right? Well, here's a tick mark, there's a tick mark. What angle are they across from? A little harder to see here, but it'd just be this little angle there. So angle F, that doesn't make sense. Hold up, reverse. I didn't go far enough down. Okay, back up, folks. I didn't feel like that was right. Okay, those are congruent sides. FG is across from this little angle there. There we go. So that would be angle FJG. Angle FJG is congruent. Now go the opposite side here. What angle's opposite side FJ? This guy right there, which would be angle FGJ. Angle FGJ. Whew. Okay. Name two unmarked congruent segments. Again, look for congruent angles. They'll be across from there. So if I look at this angle here, what's it across from? That would be side JH, which is congruent. What's across from this angle here? GH. There we go. Beautiful. Good job. All right, flip the page when you're ready. Now let's talk about equilateral triangles. So if you broke down the word equilateral, it literally means equal, and then the word lateral means side. Like you know in football, like a lateral pass is like to the side or behind them, like to the side. So equal sides. So a triangle is equilateral if and only if it is equiangular, which means equal angles, okay? So in our picture here, if we knew that the measure of angle A is congruent to the measure of angle B, which is equal to the measure of angle C, then all three of my sides would be equal. So AB equals BC, which is equal to AC. Okay? Or conversely, if you knew the opposite, if you knew that all three of our sides were equal, then you would know all of our angle measures would be the same. So the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C. So visually, equilateral triangles are quite appealing, right? Because everything's equal. So if we know everything's equal, what would an angle measure have to be in this triangle? Right, there's three of them, and they're all equal. So if we take 180 divided by 3, we get 60. So that's maybe something I would want to write on my triangle or somewhere here. So you always know that if you have an equilateral triangle, all three of your angles are always 60 degrees. Okay? Wonderful. Let's try finding some variables here, okay? Okay, so we have a triangle here, and we're looking for x and y. Well, I think we should probably find x first. So just given this information, I have two pairs of congruent legs. So my brain's thinking is that it's isosceles, okay? Okay, so it's an isosceles triangle. Here's my vertex angle, so I know that these two angles are the same, right? So if this is 2x, so is this one because they're my base angles? Well, now it becomes a pretty easy problem to solve, right? Because what do angles A, C, and B have to add to? 180, right? So I'm going to have 2x plus 2x plus 2x set equal to 180. So we have 6 total x's equal to 180. Divide out and we get 30. But now, since we just found out that all of our angles are 2x's, it's really an equilateral triangle. So, it's an equilateral triangle. I know that all my sides are the same. So to find y, we just have to simply set 4y minus 5 equal to 3. It's pretty easy to solve. Divide out. You get 2. Beautiful. All right. Again, challenge you to try the next one on your own. However, I'm going to get rocking on it right away. So again, if we look here, we have 2 legs the same. So this is another isosceles triangle. Should we find x first? So if I know my vertex angle up here is 80, how can I figure out what my base angles have to be? Well, I know they have to be equal, right? So if I have 180 degrees and I take 80 away, I'm left with 100. And I have to divide that equally between the 2 that I have left, which is 50. So now I know that this is 50 and so is this guy. So to find x, we can set 6x plus 8 equal to 50. So we'll have 6x equals 42, x equals 7. Y again is pretty simple. Those are both of our legs, and we know the legs of an isosceles triangle are equal. So 4y minus 2 equals 2y plus 2. Get your y's to the same side. Add over your 2. Divide out. We should get y equals 2. Beautiful. Good job, you guys. Okay, now the last idea we have to talk about today is this thing called CPCTC, right? What did I just say to you? CPCTC. Really, we've been doing this all chapter. We just haven't formally said CPCTC, which stands for corresponding parts of congruent triangles are congruent. Well, we already know that, right? Like if I had this triangle here, ABC, then I had this triangle over here, DEF. And we were told that triangle ABC is congruent to triangle DEF. We would know that all of our matching parts would be the same, right? Like I know A and D are in the first spot, so I would know that this angle here and this angle here measure the same, right? Those are corresponding parts. Well, now we can use CPCTC in a proof to show that specific parts of congruent triangles are the same, okay? So it's like we're taking the proofs that we've been doing for the last week and we're adding one more step. So after we're done proving them congruent, our triangles, we can say specific pieces of them are congruent, okay? So let's try this big proof here. So if you notice, you guys, we're not trying to prove triangles are congruent. We're trying to prove that specific parts of our triangles are congruent. And in order to do that, you first have to say your triangles are congruent. So maybe it's easier for you, cover up that bottom part. Cover it up. Pretend this is all we're doing. You guys have done this many times now with other proofs, right? So let's just see what they give us before we try figure out the bottom. So we have an isosceles triangle ADE, so that's the big outside one, with vertex angle E. So if this is my vertex angle, I automatically know that this is a leg, which are equal, this is a base angle, and this is a base angle. So I know all of that information simply by just being an isosceles triangle. And then the other part of our given is that AB is congruent to CD. So this guy here is congruent to CD. Okay. So all of that's just free information. And then our end goal is to show that BE is the same as EC. Well, they look the same. And if you guys notice, they're in matching spots of those two triangles on the outside. So if we can show a triangle AEB, that triangle on the left, is congruent to triangle EDC on the right, then we would have corresponding parts. Okay, so let's go through it. So we have isosceles triangle ADE with vertex angle E, and segment AB is congruent to segment CD. That's just free information. Now they're wondering, why is AE, this guy here, congruent to DE? Well, that's because legs of an isosceles triangle are congruent. So we'll say isosceles triangles have congruent legs. That's why we knew that. Then why is angle A congruent to angle B? Well, they're base angles of our isosceles triangle. So I'm going to say base angles congruent of isosceles triangles. So now what shortcut proves triangle AEB is congruent to triangle DEC? Well, that's a side marking, that's an angle marking, and that's a side marking. Side, angle, side. That's by side, angle, side. So now we can finally say that BE is congruent to CE. Now just look, you guys. BE, last and middle. CE, last and middle. If I look at my picture, they're in the matching spots. So those are corresponding parts of congruent triangles that are congruent. CPCTC. So like another thing to think about, if you're ever just trying to show that parts are the same, you automatically know this is your last step no matter what. Always, always, always. That's the only way to get there. Okay, last one, folks. Given AB is congruent to AD, BC is congruent to CD, show that angle BCA is congruent to angle DCA. All right, well, since I know I'm trying to prove parts are congruent, I have to first show I have congruent triangles. So I'm just trying to help myself out. Before this step, I know I have to show some triangle is congruent to some other triangle. Okay? So here we go. Let's mark up our picture. AB is congruent to AD. And BC is congruent to CD. That's free information. So let's put both of those on our first line here. So we have two sides the same. Can we find anything else out? Do we have anything else that we know that we can mark by just looking at our picture? Well, I see that both triangles have AC and then that middle line. So we could say that AC is congruent to AC by the reflexive property. Oops. Then from there, we can say triangle ADC is congruent to triangle ABC by what shortcut, you guys? Side marking, side marking, side marking. SSS. Side, side, side. So now that we've shown those two triangles are congruent, is that enough information to say angle BCA? So this guy here is congruent to DCA. This one here, yep, they're in matching spots. So by corresponding parts, congruent triangles are congruent. CPCTC. Woo! All right, we did it, folks. Good job. Thank you for listening. I appreciate your willingness to cooperate. You have a splendid day. Goodbye.